In this section, we want to be looking at angle relationships and similar triangles. So again, a lot of this stuff is going to be very familiar to you if you remember stuff from geometry. One of the first things we want to talk about is vertical angles. So for vertical angles, it's something that looks simply like this. Okay. Basically, two lines that intersect will form pairs of vertical angles. For example, these guys would be vertical angles, and that means that these guys will be congruent to each other. Vertical angles are congruent. So if I label these, let's say 1, 2, 3, and 4, we could say that angle 1 is congruent to angle 3. In other words, the measure of angle 1 equals the measure of angle 3. So we use congruency. We use, this is the congruency symbol. We use that symbol when we're talking about physical constructions, like line segments being congruent to each other, angles being congruent, triangles being congruent. When we want to talk about something specific like the measure, then those things would be equal. You'd use an equation like what we have right here. Now, that being said, you could look at angles 2 and 4, and since these guys are also vertical angles, we can say that angle 2 is congruent to angle 4, which means that the measure of angle 2 is equal to the measure of angle 4. Again, vertical angles. One of the other big concepts that we have is talking about parallel lines. So remember that parallel lines will look something kind of like this. They are going to be two coplanar lines that never cross, they never intersect. Now, parallel lines are cool and all, but what's really cool is when you start doing something like this, you throw a transversal up. So a transversal is just a line that will intersect two or more lines, okay? So let me label these. So I want to say label 1, 2, 3, 4, 5, 6, 7, and 8. Okay. When you have parallel lines, and a lot of times you'll see this designation on them, something like this, to denote these two guys kind of go together and they're parallel. You have all different kinds of classifications of angles. You have corresponding angles. So corresponding angles are just those guys that happen to be in the same position but on different corners. For example, angle 1 would correspond with angle 5. Angle 2 corresponds with angle 6, and so on. Angle 3 corresponds with angle 7, and angle 4 corresponds with angle 8. Well, when you have two parallel lines cut by a transversal, these guys end up being congruent. So you've got that there in the notes. Corresponding angles are congruent. So in this diagram, we could say that angle 1 is congruent to angle 5. We could say that angle 3, using a different color, really using two arcs instead of just one, we can say these guys are congruent. Now, because we have straight angles here, there's a lot of extra stuff that just kind of falls out from this. But let's talk about some of the other types of angles that we have. So we have hold on. I left out a letter. Sorry. We have alternate interior angles. So these are going to be angles that are on the inside of these parallel lines, and they're going to be alternate, so on opposite sides. So we're looking at angle 3 and angle 6 would be alternate interior angles, and angle 4 would be an alternate interior angle to angle 5. And these guys happen to be congruent. So I'm saying that 5 and 4 being alternate interior angles, these guys are congruent. 3 and 6, these guys are congruent. That's pretty cool. The same thing can be said for alternate exterior angles. So these are going to be the guys that are, again, on opposite sides of the transversal, and on the outside of your parallel lines. So alternate exterior, so 1. So on the other side of the parallel lines and on the other side of the transversal. So angle 1 is an alternate exterior angle to angle 8, and angle 2 with angle 7. These guys will be congruent. And you can kind of see the logical conclusion here. If you look at, say, why is 1 congruent to 8, right? So 1 and 4 are congruent because they're vertical angles, right? Or you could say 1 and 5 are congruent because they're corresponding. But 5 and 8 are vertical angles, so there's this transitive property here. So 1 is congruent to 5, which is congruent to 8. Or 1 is congruent to 4 because they're vertical angles, and 4 is congruent to 8 because those are corresponding angles when you've got these two parallel lines cut by a transversal. And then we have some kind of weird, I'm not going to say weird, but it's just not things that are congruent. So we have same side, interior, and exterior angles. So those are going to be guys that are on the same side of the transversal and either on the inside of the parallel lines or on the outside. So same side interior will be, say, 3 and 5. So angle 3 and angle 5 are same side interior, just like 4 and 6 are same side and interior. Angle 4 and angle 6. Same side exterior would be 1, and on the same side of the transversal, but on the outside is 7. So angle 1 and angle 7, and then the last pair, 2 is on the same side as 8, and they're both exterior to those parallel lines. So angles 2 and 8. These guys are not congruent. Instead, these guys are supplementary. Now remember that supplementary means that they add to give us, add to give us 180 degrees. So keeping that in mind will help us answer a lot of these other questions that we have coming up. In fact, let's do one real quick. Let's see if I can get this to work right. Oops. So here is a problem that was from the notes, and we have 117 degrees right here. And we want to find the measure of all the other angles. So what we have here is that we do have parallel lines cut by a transversal. Let's get the measure of every other angle that we have here. First of all, because you have vertical angles here with that, we know that this angle measure is 117 degrees. Cool, cool. Now, we know that we have parallel lines, so that means we have corresponding angles being congruent, which means 117 here corresponds to this guy right here, which makes him 117 degrees. And this angle corresponds to this one, which is also a vertical angle there, and this is 117 degrees. What about the other angles? Well, if we pay attention here, this guy right here is straight, which means we have supplementary angles with the 117 and the angle that's right here. So if we do the subtraction, we do 180 minus 117, we get 63. So this guy is 63 degrees. So is his vertical angle over here. Now, another way that we could have gotten this 63 degrees is by recognizing that these two angles are same side interior angles, which makes them supplementary. So one of the cool things about these examples is there's so many different ways to get to the answer. You just have to make sure that you keep an open mind about it. Well, since we know that's 63, that means this guy has to be 63 degrees, and so does this one. So there we go. We have the angle measures for everything in this diagram. So let's take a quick little break, and let's see what happens with the next two examples.